Hello, everybody, and welcome to the AutoCall Fire Detection Academy's webcast series. This is a new series of courses that's designed to deepen your understanding of some of the key features and technologies we have within the AutoCall product line, and to deliver a deeper set of knowledge and understanding than you would get out of a normal launch webcast. The launch webcast series are designed to bring awareness of the product and to help you understand the features, benefits, and applications. But we recognize that once you really get into the product and start selling it, other questions arise that are usually, how do I do this? Can I do this? Does it do that? What applications can I really do with the product once we begin to apply it? So the idea of this session is to serve as a bridge between the launch presentations, which are about the 20,000 foot level, and coming to a full-blown multi-day class in a JCI Fire Detection Learning Center. So that's the plan for the program here, and we're going to take this time and kick off the discussion today of ESNet, Fire and Life Safety Network, which is our most advanced IP-based fire network we've ever released. So my name is Brian Shifley, and I am on the JCI North America Learning and Development Team for Global Fire Detection Products here at Johnson Controls, and I'm based out of Westminster, Massachusetts. So I lead the team of trainers that are responsible to deliver our fire detection training to you either virtually or instructor-led in one of our classrooms. Today, hosting the content for you will be James Adams. James is a highly experienced senior trainer on the L&D team. James has many years of experience with our product lines in the classroom and is the senior developer for ESNet. I'm excited to have James here as the expert to present this material and to answer your questions at the end of the presentation. And please feel free to bring any questions you have about the technology, the integration, and just how all this fits together. So whatever questions you have, feel free to bring those up. So a couple of housekeeping items before we get started. So everybody in the session is on mute. And that's really important because the microphones are live. So if you unmute yourself and talk, you'll be heard by everybody. And so we're going to have you on mute to eliminate any of the background noise. So also, this session's being recorded. So if you have any concerns about your privacy or don't want to be recorded during this session, which will be published later to autocall.com in the product launch webinar section, then I'd recommend that you drop off the call now. Also, in terms of questions, what we're going to do is we're going to hold questions until the end of the session, where we'll open the floor to you for Q&A. You can ask questions verbally, meaning you can unmute your microphone and you could speak out. And you could also use the chat interface here on Teams to type questions at any time during the presentation. So everyone will see those questions that you type, and they too will be part of the recorded session. So with that, I hope you enjoy the session with James, and I encourage you at the end to participate and ask some questions. So with that, I will turn it over to James Adams.
Okay, thank you, Brian. Again, this is James Adams, and this webinar is basically the first in a series on ESNet. This is designed not to be the end-all be-all for ESNet, but just give you a introductory high-level view of the ESNet as we bridge to different aspects of the product. So this first one, basically primarily, is a ESNet fire alarm network product overview to give you a real introduction into the inner workings of the product. Okay, so basically, to begin with, we'll just go into the highlights of what is ESNet and how it works as it exists today. So basically, ESNet is IP-based technology utilizing Ethernet or fiber, as well as twisted shielded cable or twisted cable or copper utilizing DSL format. We can go as fast as 100 megabits use Ethernet or fiber, DSL over copper. It gives you longer distances, but the speeds are limited to 12 megabits and down to 2 megabits per second. And that's all distance dependent, as well as the cable being used. We have high-speed network programming. The neat thing about the ESNet is a technician can program the entire network from a single point of entry at any node. And so there's no need to even travel between panels regardless of the distance. In lab exercises, we were able to, in the lab, download to 99 nodes in less than 5 minutes. So that basically greatly improved the productivity of your network. We provide advanced network diagnostics. In the past, we used a third-party application to do diagnostic analysis of our networks. We now have our own proprietary diagnostic tool to allow us to analyze or report the performance of our network down to each individual port on each individual NIC card by panel. Thereby meaning that you have a better uptime and you can actually give you faster troubleshooting without having to rely on external sources. The NICs themselves, because of the speed that we're going to be transmitting up to 100 megabits, there is a bottleneck between the NIC and the fire alarm panel. So the NICs themselves have extremely large buffer to avoid any data buffer overflow between the NIC and the CPU of the fire alarm panel. So again, that increases the performance of our network and makes it more and more robust configuration. We support multiple loops on ESNet. We can have up to 7 loops, and that's used typically in conjunction with the TrueSight workstation. So it gives us an overall capacity of ESNet to support 687 nodes on one individual site. We also support multiple topologies. People thinking of a network as a single ring. We actually support a wide variety of topologies: star, ring, bridge rings, rings with spurs, any combination thereof. We'll go over that later in this presentation, exactly how that works. We also support what's called supplemental traffic. Our network is designed to cover traffic in addition to our fire alarm traffic. So we can actually utilize it to send video, for instance, or if you have a TrueSight workstation client, we can transmit the data that way over our proprietary network. The traffic itself is separated, so there's no interference between fire traffic and supplemental traffic. And we'll talk more about that in this presentation as well. Expanded media support. So basically, as I mentioned before, we utilize Ethernet, DSL, and fiber. So we can actually, your network doesn't have to be composed of one media or the other. Each link between panels can be composed of a different media type. So we can mix fiber, Ethernet, DSL on the same network. Just be aware that, again, DSL links will be limited to 12 megabits per second, which does not really have any impact on fire traffic, but does have an impact on any kind of supplemental traffic that you're going to be having. So you won't be able to use the supplemental traffic channel if you have a DSL link. Okay. What we don't do right now is we can't use a customer's LAN for our network. This is something that we're working on for a future release, but currently we are only allowed to use our proprietary Ethernet connections between the panels, not using the customer's LAN. Okay. Also, network synchronization between nodes is not currently supported on ESNet. That is on a very soon release. Actually, it's going to be shortly, in a month or two. We'll be able to synchronize between nodes, but currently it's not a feature of the current release of the ESNet. To support the current features of the ESNet, the panels need to be at revision 5.02 or higher. Of course, ESNet only supports ES panels. No older generation fire alarm panels are supported. ESNet itself has a base support of 4.02 or greater, but to support the current features, you have to have your ES panels at 5.02 or higher. Okay. Neat thing about ESNet is our multi-loop and various topologies that we support, giving us extreme flexibility. So basically, the basic of the ESNet is a ring architecture. That's the basic building block from which the ESNet is built. So you can have a single ring of 99 nodes if that's how you so desire. But we also support various other topologies. So we have a class X single loop, which is the most common, or you can have a class B single run, or you can actually combine the two into bridging rings, rings of spurs. You have a hub panel with a series of redundant rings, or you can have a simple star where the nodes are coming off of a single spur design. So any combination thereof is supported. One thing we can't support, if you configure your network and then if wind up you have what's called a ring of rings. That is not supported by the network and be deemed invalid, and you will have issues with your network stability, and you may have initialization problems and things and everything else. So just be aware that we can't have a closed bridge configuration. Depending upon whether or not you are permitted to do so by local codes, we can spur off of one panel for one node that's out by itself, and there's no way of bringing two connectors or to complete a loop. We can actually bring out a spur for that panel. Again, this is not really UL compliant for a lot of situations. So, but we can do it as you see fit. Now these spurs are on a single port at the hub node, so you may have to add additional hardware at the hub panel to support the spur. Which brings us to the hardware itself, that is the backbone of the ESNet network. Currently, there are 3 types of network interface cards we utilize on the ESNet. We have what we call a slot NIC. We have one that's called a flat NIC, and we have an external NIC. All right, the slot NIC is used in 1400 ES panels, much the same way as any other older generation card that plugs into the secondary slot of the master controller. The flat NIC is a 411 card that plugs into the PDI, and the external NIC is just that it is a self-contained network interface card that mounts in its own CAN, and it's used exclusively for TrueSight workstations. Each one of the NICs, regardless of the type, has 4 built-in Ethernet ports that we call A, B, C, D. Okay, A and B are the 2 ports that can use as fire alarm ports. And because they're Ethernet, they get the full speed of 100 megabits per second. Because they're Ethernet, they're limited between nodes of 100 meters or 328 feet. These connectors are Cat5, E or better. So you can use, if you have a Cat6 infrastructure, we can use that as well. Ports A and C provides us with a UL compliant earth fault detection for our network loops. So let's take a closer look at the slot NIC. It is an E-slave. It consumes 1 slot. As I mentioned before, it can be plugged into the master controller motherboard in the secondary slot. If for some reason that slot is occupied by another card, you can install the Class B motherboard in order to utilize this card. Now, you can have multiple of these cards installed. One card for the local panel and another card for the TrueSight workstation to utilize. Okay, and the configurator, it actually would say is a ESNet NIC, which is used by a local panel, or is the ESNet TSW NIC, which is used by the TrueSight workstation. The flat NIC is a 4x11 card. It can be used in any one of the ES panels, the 4010, 4100, or 4070S. Again, it has all 4 ports, just like the other cards as well. And it also can be utilized for local panel or utilized to connect to the TrueSight workstation. This kind of gives you an idea of how this card fits into the panel's internal infrastructure. Typically, in a panel, you have the CPU card with the Ethernet port, and that connects directly to the front panel Ethernet service port. What we do is insert the ES slot NIC into that internal communication bus, where now port C on the NIC, whether it's slot or flat, plugs into the CPU card of the fire alarm panel. Port D connects to the door for the service port. So that gives a technician the ability to plug into the service port and either talk to the local panel directly or talk across the network to any other node. Okay, utilizing the Ethernet connections. With the 4007 mounted is unique in the fact that we have a special bracket made just for the NIC card that allows us to install the card over hardware that's installed in blocks G and H of the two-site work of the 4007 ES. It basically has a double standoff configuration, so we can have two cards on top, one on top of the other. The key thing here is when you order the NIC, flat NIC, you want to make sure you order it for the correct panel, because the included hardware will support the mounting requirements for that particular panel. So for 4007, you want to make sure you order the 4007 part. Okay, this is the external NIC, which is used exclusively by the TrueSight Workstation or Instant Commander. It comes in two models and in two colors. Each model, we got 120 volts or 24 volt AC. We also have a 24 volt DC, which is the one that's shown here. And basically, the 24 volt DC design, you can actually connect this to a panel that's close by, or use a UL listed fire alarm power supply to provide power to this unit. It's designed to be close nippled to the TrueSight Workstation. It's 10 by 10. All right. Again, 4 built-in Ethernet ports, but because of the configuration, it only supports one expansion media card. So the number of ports available for fire alarm network is limited to 4, as opposed to the other cards, which can have 6. Okay. Now, these NICs, as I mentioned, are not mounted in a TrueSight Workstation Instant Commander. So basically, for a TrueSight Workstation to connect to a network, a NIC must be mounted either in a ES panel or use the external NIC to facilitate the connection to the network. Just like the CPU on the fire alarm panel, the Ethernet port of the TrueSight Workstation plugs into port C of the NIC to communicate with the NIC. Okay. So basically, depending upon how it's configured, you can utilize either an external NIC or a flat NIC to facilitate communications of the TrueSight Workstation to your ES network. And so basically, as you see here, you have a Class X loop, which is your typical ESNet network with an external NIC connected to the TrueSight Workstation. So you have a Class X pathway for your loop, but the connection between the TrueSight Workstation and the ESNet NIC, whether it's a slot, flat, or an external, would be a Class B pathway. So basically, if it's 20 feet or less, it does not have to be supervised for ground faults and things of that nature. But once you get greater than 20 feet, it has to be supervised for ground faults and also installed in conduit as well. So the proximity between the TrueSight Workstation and the NIC comes into play as how it's installed. Okay. All right. Okay. So in a network where you have more than one loop, the TrueSight Workstation can be integrated on those loops. There'll be a NIC for each loop at the TrueSight Workstation. But instead of trying to install 7 Ethernet ports on the TrueSight Workstation, we can install a UL listed, or UL approved rather, Ethernet switch and connect that to the TrueSight Workstation, and that'll be the bridge to each loop on the of the fire alarm network. So basically what you can have here is I'll have the TrueSight Workstation going to an Ethernet switch, and off the Ethernet switch up to 7 NICs. Now here we can either have external NICs, or actually what we can do is we can mount all the NICs in a fire alarm panel and connect those to the TrueSight workstation that way. And it can be done in any combination thereof. You don't have to dedicate it to all externals or all panel mounted NICs. There can be a combination of the two, as long as they do not exceed a total of 7 loops at the TrueSight workstation. And basically, to make it easier to facilitate that, we actually have a bracket, a vertical mounting bracket that allows us to install flat NICs, multiple flat NICs in the same bay of an ES panel. So now we can actually have 7 ES loops inside a panel. And all we have to do is make sure there's sufficient power in that panel to provide with the cards. Now, the ES panel itself does not communicate with these cards, it only provides the power. The TrueSight workstation is the one that's communicating with these cards. The panel just acts as a repository for the cards. Okay, this kind of shows the way it's connected. Basically, you have different types of cards on your network loop, and can also have different kinds of media as well. So we just go from one port to the other as you make your way around the network, just one fire port to another fire port on the adjacent panel. We can mix and match media. Just be aware that if you do have a DSL on your network, that link is going to be of a slower speed, and it also limits you as to what you can do with ancillary communications. Okay. All the cards that we use, the media cards, they are dual channel. So you have a port and a B port on each card, whether it's fiber, media, or DSL. So basically, at each end of the link, you just have to make sure you have the proper media card installed. And depending upon how your network is configured, you may have 1 or 2 media cards installed on a NIC. Now, of course, if you use a spare, you may have a situation where you have multiple Ethernet media cards installed to increase the number of ports from 2 to up to 6 Ethernet ports. One of the things we don't is the audio riser for ES for the network. One of the things we are working on is to incorporate the audio into the riser aspect of the ESNet. So instead of having a separate riser for your firefighters' phones going between nodes and a separate riser for your audio evacuation messages, they will all be done over the ESNet backbone. And that is basically a future release for the product that's actually being worked on right now. These are the 3 media cards types that adds the number of ports and media types to the ESNet NIC. Each card has 2 ports of one type, whether it's fiber, DSL, or Ethernet. The slot and flat NIC supports 2 of these cards. To add 6 additional ports to the card, the external NIC only supports 1. This is a dual channel Ethernet. Again, just like what's on the resident on the NIC itself, is 2 10-base, 100-base T ports, and each port can be configured to work as either a fire port or supplemental traffic port, and giving us up to 100 megabits of speed over the port. Now, again, the distance limitation is 328 feet, 100 meters. And again, the recommended cable connection using RJ45 Ethernet connector is Cat5e or better. So we do support Cat6 in our network. For the fiber, we have dual mode ports. We support multi-mode fiber and single mode fiber. Of course, we can't mix those in the link, but we do have the ability to support those if your customer's infrastructure has one or the other. So there's 2 100-base bidirectional fiber optic ports. Okay, so a single fiber between nodes. We don't have to have 2 fibers, it's just 1 fiber between nodes per link. Again, we support single mode and multi-mode fiber. Of course, that gives us extremely long distances between nodes, utilizing those media. Our panels, NIC cards use SC fiber connectors. If your customer has existing fiber with ST connectors, there is a service kit available, so we can retrofit that connector to SC without having to rework the fiber. A dual channel DSL, again, this is not our first choice to use, but it's basically used if you're utilizing a retrofit installation where all the customer has is copper wire going between their infrastructure. So we can utilize the existing copper wire. We use a Phoenix connector, plus minus shield in order to facilitate the connections. So this gives us a relatively good distance between nodes. It's just the fact that, again, the speed of the link is reduced to 12 megabits per second. And this is distance dependent. The further you go, the slower the speed for DSL. So this is the part numbers for the hardware. Again, the data sheets for the hardware is available on AutoCall's Network Exchange on the autocall.com website. So give you a full description of each one of the pieces of hardware and the panel compatibility and, of course, the part numbers associated with it. The wiring specifications for ESNet, again, we can use fiber, whether it's single mode or multi-mode fiber, utilizing SC connectors. And of course, the output power is dependent upon which fiber you use, and what's allowable loss is also relative to the type of fiber being utilized. Okay. And of course, with fiber, we can still use the full 100 megabits per second capacity for each link. For DSL, 18 gauge wire is preferred, unshielded preferably as well. Unshielded works best in the longer runs for high speed communications. We can get up to 15,000 feet using 18 gauge wire, or we can even use, if you so desire, Cat 5e cable as the medium. Just be aware that the distances is going to be a little less, okay, depending upon the distance between the panels. We can use shielded or unshielded. Unshielded is better, but shielded provides us with the UL required supervision for ground faults and protection against any kind of environmental issues as well. And again, if you have a DSL link, you cannot use supplemental traffic at all in your network loop. Okay, which brings us to discussion of what is supplemental traffic. I've been talking about that a lot. So this is what supplemental traffic is. Okay, so currently we use 100 megabits a second for our network loops. Fire traffic only uses a fraction of that bandwidth, which means we have a large section of the bandwidth not being utilized by the fire alarm control and traffic. So that allows us extra bandwidth to send video or communications to remote clients and things of that nature over our existing network. And then we call that the supplemental traffic channel. And if you want to look at that, just imagine a highway of sorts is our ESNet network, and you have a dedicated lane for fire alarm traffic. So basically, the two modes of communications do not interfere with each other at any given time. If the fire alarm traffic needs more bandwidth, we will throttle down the supplemental traffic channel to do so. If the supplemental traffic channel needs more bandwidth, then it's just going to have to live with what's available, because we throttled that we cap that at a maximum of 80 megabits per second. And the whole idea is that the fire traffic will always, regardless of the conditions, have proprietary over the other traffic on the network. Okay, so basically, just give you a scenario here. Here is a network. We're utilizing a fiber backbone. That's what we're using ports E and F in each one of the nodes. And so the external NIC, the TrueSight workstation server, has an external NIC, and it's plugged into port C. And we have clients on the site, and we can take any one of the unused fire ports and set it up as a supplemental traffic channel and connect the client computer to that location. So even though between its client and the NIC is Ethernet, which gives 100 meters max, because we're using fiber, the actual real distance between the client and the server can be tens of thousands of feet, and all within our proprietary enclosed network. We can also use video, so you can actually take a recorder and plug it into one port that's designated as supplemental traffic, and throughout the campus, you can bring IP cameras and plug them into the supplemental traffic ports designations at each one of the nodes, and the video will be transmitted across the network to the hub equipment for the video. Again, the video traffic and the fire traffic will never interfere with each other under normal circumstances. Okay. To better enhance the usability of our network, we have a diagnostic tool that allows us to be able to troubleshoot our network more effectively. So basically, it's a PC-based standalone application and allows a single technician to troubleshoot the TrueSight workstation. All one has to do is install the application on one's laptop, which is available. The software is available at article.com as part of your support download pages. And the software is limited to TR only. Basically, you have to have a TR license to be able to run the software. So I can take my service laptop with the diagnostic tool running and connect to any service port of any node on my network, and I can go through and analyze individual ports of individual NICs at nodes. So I can actually look at the performance of each individual port. If the end user has a license at the TrueSight workstation, we can also use the TrueSight workstation as a means to diagnose the network as well, as long as they have a valid license to run the diagnostic tool. And to give you an idea, basically one of the neat things about the diagnostic tools is that it gives you a full real-time topology of your network. It shows each node, the connection between each node. It gives a node number, the node's nomenclature, and utilizing icons, it actually will show you where there's troubles that exist in your network. Okay. And so basically, this is a real-time connections of your TrueSight of the ESNet network. So you can actually, let's just say you don't like the way it's being represented, because in larger network, because the screen may be cluttered, you can actually move the icons manually to be a display that's to your liking, and save it as a snapshot, and that'll be permanently how the network is arranged. So we can let the software display things as they are, or you can use your own the mouse to rearrange the icons. We have a means of looking at each port individually. So this particular case, this example here, we're looking at a link down situation. So the technician plugs into the diagnostic tool into the service port, calls up the port in question, and a graph is shown, which shows across the bottom is the date, and the vertical is the time in seconds. So basically, we can see not only how long the link was down, but when the link was down using graphical format. That allows a technician to easily discern what activity was occurring when this link was down, and helps them in their troubleshooting abilities. Now, this graph can be displayed in either day format or accumulations over a week format. Okay. And one of the things we have is the diagnostic tool gives us is the overall status of the network. So any troubles that exist on the network, we have a function called network status, and it gives you a listing of all the current troubles that exist on the network. And it's geared around like link downs, miswired links, ground faults, version control mismatches, extra nodes, duplicate nodes, missing nodes. It does not just tell you that these troubles exist, but tell you exactly where on the network these troubles exist. So again, you don't have to go through and try to figure out what's going on. It actually tells you what's going on and where it's happening. And this can be displayed not only at the diagnostic tools, but also the front panel display has a network status menu item that pulls up this information as well. And if you have an info alarm, it has its own menu, and also the TrueSight workstation, and we can pull this information up as well. So basically, I can go to any node on the network utilizing the diagnostic tool or the front panel display to discern what general troubles are occurring in the network. Okay, so basically, the resources available through your knowledge exchange on the AutoCore website. It gives you the product description, the data sheets. We can go through each one of the data sheets for each one of the products. And of course, these are updated with every release. And as well as the technical documentations for the installation manuals, okay, for each one of the panels, as well as the hardware associated with it, the installation instructions, things of that nature. Okay, all right, and last but not least is the training. We can go beyond these webinars, and we have classroom-based training as well as online e-learnings that's being developed that allows us to provide training for sales and technicians. In the classroom, we do have a sales applications training, and we also have a one class dedicated to ESNet and another class dedicated to TrueSight Workstation on ESNet, which includes graphics, editing, things of that nature. So you basic technician comes to a class, they'll learn how to create, install, program, operate, and troubleshoot an ESNet network utilizing the tools we just talked about, as well as a separate class to the same thing. And now we're talking about a TrueSight Workstation. Okay. So with the current condition in place, a lot of things are being converted to online trainings. We're doing a lot of e-learning that's going to be available, and you should be receiving announcements that tell you exactly what e-learning is available for your particular product that you desire. Okay, so once classroom training, of course, resumes, you'll be able to contact us or go onto your resources website to schedule or sign up for the classes. And that pretty much is it for the ESNet high-level overview. Back to you, Brian.
Well, thanks very much, James. Thank you for the presentation. We do have a question here in the meeting chat from Richard Martinez, and he asks, is this technology approved by the New York City Fire Department for New York City? And how about the rest of the state? I have posed that question to the product manager, and I am waiting for an answer, Mr. Martinez. So once I do, I'll send a note out to you and the rest of the team on the call so that people can see. And so I don't have an answer for you right now. I don't know, but I'll find out. Second question, James. It's from Bryce. If I only have one 4100 ES with an incident commander and one TSW, do I need two external NICs, or can they be wired together on the network?
Well, basically, each node has to have its own one NIC for each node. That's basically all you need. So the actual NIC for the TrueSight Workstation and one NIC for your ES panel. Either flat or slot.
Okay, excellent. Thank you very much. Does anybody have a question that would like to ask to James? If you do, please unmute your microphone and you could be recognized. Go ahead. No questions for James on the Friday afternoon. Okay. Well, James, thank you very much for your presentation this afternoon. Much appreciated. And to the audience out there, thank you for joining us for today's ESNet presentation. And we'll see you at the next webcast. Stay tuned for that email. Thank you very much, and everybody have a nice day.